This is the applied video for Biomechanics 376. This is group number 8. The skill that we'll be doing for applied video project is having an individual walk in a straight line, and also we'll have another individual who is injured walking also in a straight line. The concepts that we will be talking about and pointing out and explaining in a little bit more detail are ground reaction forces, balance, base of support, velocity, and visual search. So the first concept we will talk about is ground reaction force. So ground reaction force is actually defined as the force exerted by the ground, which is equal and opposite of the body's force exerted on the ground at a given point with the help of Newton's third law of reaction. Additionally, ground reaction forces represent the summation of the acceleration of all body segments and reflect the movement of all body segments in the entire body of center of mass. So ground reaction forces can be seen in the skills shown, which we're going to show a little bit later, but I'll talk to you about it when we're showing the actual video. So it can be shown by the amount of force exerted being exerted back onto the individual's heel. So once the individual who is uninjured continues their gait, which is defined as a person's manner of walking, which will be shown in an injured person and an uninjured. The uninjured person will be Jake, and the uninjured person will be Miles. They will begin to transfer the force exerted onto the ground from the heel contact to the point of toe off. So in an individual who is injured, their gait will be affected by the amount of heel contact they have and the lack of toe contact to propel them in the desired direction. So additionally, the gait will be altered because they are preventing themselves from putting the maximum force onto the affected limb that has the injury, which will subsequently alter the transfer of force from one leg to the next, known as the stride-to-stride interval, and we'll go a little bit more into detail on that. The next principle we will talk about is balance. So balance can be defined as the ability of an individual to control their equilibrium. Please don't confuse this with stability, because stability is defined as the resistance to disruption of equilibrium in a linear or angular acceleration. However, balance is essential for an individual to walk in a straight line, such as base of support. Base of support can be defined as the area enclosed by the outermost edges of the body in contact with the supporting surface. So in this case, the larger the stride in the individual will result in a greater base of support, which will likely increase the individual's balance. There are some factors that can affect someone's balance. However, we're not going to go into that because it will become a much longer video. One thing that should be pointed out while an individual is walking is the use of proprioception and sight. So the use of proprioception is defined as the sense of self-movement and body position with regards to another object. In addition, proprioception, an individual uses their sight to find the next place to set their foot. We also have to be aware that sight is the most dominant sense that we do have. So it is very vital that we use sight and proprioception when walking. The next thing we're going to talk about is velocity. And so the way to determine velocity of an object is by calculating it by the height of one step, which is also multiplied by the number of steps, and then it is all divided by the amount of time it takes to travel that distance, or also known as the change in distance. So velocity can be defined as the change in displacement that occurs in a given time period. So on the other hand, momentum is defined as the quantity of motion of a moving object measured as a product of its mass and velocity. So it is not possible for an object to have momentum if there is no velocity. The faster an individual takes to cover a distance, the higher their velocity is subsequently their momentum. In the case of the individual walking in a straight line, the direction of the object's movement would be in a vertical direction instead of a horizontal direction. The last principle that we're going to talk about and discuss is called visual search. So visual search can be defined as the process of directing attention to the appropriate visual information. We did touch on that when we talked about proprioception with the use of sight, but visual search goes a little bit more into detail, and I'm going to explain a little bit more. So of the 5 senses that humans have, the use of visual sense is deemed the most dominant, like I said before. We've touched on proprioception and sight and how it can play a role in walking up a set of stairs. However, we're going to use it in walking in a straight line. The use of visual search helps us scan the environment with the use of exteroreceptors to fixate on some objects that might be in the way that could potentially harm us or even prevent us from continuing on our intended path, which in this case is walking a straight line. So for example, we could have a backpack that's in the way and we need to go around it because we want to go from point A to point B, and our mind thinks that we need to go in a straight line, so we have to detour around a possible object with the use of visual search. The use of proprioception tells us about the body position and joint placement. So for example, our bodies use the visual search process to determine if there are objects in the way of walking up the stairs or in a straight line, which would prevent us from continuing with our intended path. However, using our sight will notice that an object is in front of us and it will create a problem whether it is small or big. In the case of the injured individual who has a limp, it is the response to having an object in front of us or possibly just a slight stoop or uneven concrete, their response is going to be much higher. So what they're going to do is they're going to have a heightened proprioception when it comes to their sensors, because they're going to be more likely to be more cautious because they're already injured, so they don't want to become even more injured. So next we're going to show the video of both an injured and uninjured person walking, and we will point out the certain specifics of all the concepts that we talked about. Here we have Miles, who is an uninjured individual. As you can see, there is a transfer of force from right foot to his left foot. As you can see, that there's a heel contact and then a transfer of force from heel contact to toe off, which is in a backwards direction, which allows for the transfer of force from his right foot to his left foot, propelling him forward. As we watch Miles one more time, we can see that he has a long stride. In this, we can assume that he's using visual search and also the increased base of support, which allows him to have balance. With visual search, you can see that there's no object in front of him besides those sets of stairs. In this, if he were to have stairs in front of him, he would have to use visual search to see that there's an object in front of him and make the appropriate actions to prevent him from falling. Here we have Jake, who is the injured individual. As you can see, he has a limp on his left leg, which means that he has a heightened proprioception and visual search. Another thing to point out is the fact that he has a shorter stride, which means his base of support will be much less. In addition, something that should be pointed out is that there is no transfer of force from his right foot to his left foot due to the fact that there is not a lot of transfer from heel contact to toe off. We hope you enjoy learning about ground reaction forces, balance, base of support, velocity, and visual search.